Okay, so what we're going to look at today is solving inequalities. Now I'm going to do this slightly different to the way Alan does. I'm going to not worry about the greater than or less than sign at all. I'm just going to look at the equals. So x squared minus x minus 6 equals 2x plus 4. And I'm just going to solve this to find what I call critical values. So if we take everything to one side, we get x squared minus 3x minus 10 equals 0. What we've got here is a nice simple quadratic. So I'm looking for two numbers that multiply together to give 10 and add together to give 3. So that's 1 and 10, 2 and 5, so it's probably the 2 and 5. So x minus 5, x plus 2 equals 0. When does that equal 0? X equals minus 2 or x equals plus 5. When is this one 0? When x is 5. When is this one 5 minus 5 is 0? And this is minus 2. So these are what I call our critical values. This is when they are equal. And now I'm just going to test points. So I know they are equal at minus 2 and 5. So I'm going to test some points. And for this, what I'm going to do is I'm just going to test points inside. So here I might test x equals 0. Here I might test x equals 10. And here I'm going to test x equals minus 10. So in the middle here, you get is 0 squared minus 0 minus 6 greater than 2 times 0 plus 4? That's no. Here I'm going to get, so all I'm doing is substituting it straight into these values right up the top to see whether this is true or not. So at x equals 10, I'm going to get 10 squared minus 10 minus 6. Is that greater than 2 times 10 plus 4? And the answer there is yes. So it's true for that section. And is it true for this section? I'm going to get minus 10 squared, which is 100, minus 10 minus 6. Is that greater than 2 times minus 10 plus 4? And the answer there is yes. So it's equal at these critical values. And once we know where it's equal, either side of that, it's got to be greater than or less than. Okay. Another way perhaps to look at this is to do it graphically. If we wanted to graph y equals x squared minus x minus 6 and y equals 2x plus 4, so it's exactly the same question. And we want to look at where this is bigger than this. This is a quadratic. And if we solve this quadratic or separate it down, you get x minus 3, x plus 2. Two numbers that multiply together give minus 6 and add together give minus 1. So it crosses at 3 and minus 2. And this is a graph that will look like this. And again, it crosses at, I've stuffed up a little bit there, but it crosses at minus 2, and the parabola crosses at minus 2 and 3. And if you remember, the critical values we had before were minus 2, that's where it's equal. There's one critical value. The other critical value is 5, which is going to be off the page, which is a bit of annoyance. But that's where they're going to cross. And where is this parabola greater than the line? It is bigger than the line here. You can see that it's above the line, and it will be above the line when it crosses off the page up here. So for these values and for these values, it's bigger than. So that's the other way to do it. And again, we can write this as x is less than minus 2 and x is greater than 5. I'm not sure if I wrote that on the last one, but obviously you need to write your answer too, which I forgot to do on the first one. If we look at absolute values, which graphically can be quite difficult, again, I just straight away look at the equals case. So when is 3x minus 2, the absolute value of that, equal to x plus 6? And I just solve that. So when we're solving the absolute value, this could be 3x minus 2 equals x plus 6, or 3x minus 2 equals minus x minus 6, the negative of it. Now these are linear equations, so they're quite easy. Take this over, you get 2x equals 8, so x equals 4. Take this over, you get 4x equals minus 4, so x equals minus 1. So again, these are our critical values. And once we've got those critical values, we can just test them. When x equals, and we're going to test them in here. So draw a little number line again. We've got x equals minus 1 and x equals 4. Test some values. So again, test 0, test minus 10, test 10. Is the absolute value of 3 times 10 minus 2 greater than 10 plus 6? The answer there is yes. What about at 0? Is the absolute value of 3 times 0 minus 2 greater than 0 plus 6? The answer is no. And then I can test the last one. The absolute value of 3 times minus 10, that's minus 30, minus another 2 is minus 32. Is that greater than minus 10 plus 6? And the answer there is yes. So unlike the first question, it's always nice to write. So x is less than minus 1 and x is greater than 10. So what we're really looking at is this area and this area. That's where it holds. If we wanted to do it graphically, we could graph these two things. First, we've got y equals the absolute value of 3x minus 2. 3x minus 2 looks like this. Where this would be minus 2. And we want the absolute value of it, so nothing underneath is allowable. So it would look like this. That's the absolute value of 3x minus 2. And then we've got y equals x plus 6, which is a line like that, where that is the point minus 1, and this is the point 10, x equals 10. Well, this is the point minus 1, and this is x equals 10. And again, where is the absolute value graph bigger than the other graph? It's bigger than it here and here, which is x is less than 1 and x is greater than 10. Okay, so hopefully that has helped you with another way to look at, another 2 ways to look at those type of questions. Thanks.